friends, this is Anusha back to you with a new video. If you still did not subscribe our YouTube channel, please subscribe it. If you like this channel, please share to your friends and don't forget to click on bell icon. Thank you. Let's start our topic is acids, bases and salts. So what are acids, bases and salts? In your class 7 and 8 you have learned about these acids and all. To the extent to that topic, more knowledge you will gain in this lesson now in your class 10. So what are acids? The basic thing what you know about the acids are nothing but which are sour to taste, if you taste it, it will be very sour to taste. It is sour to taste. Turn blue litmus paper to red litmus. What are these litmus papers? And some are natural indicators are also there, like cabbage juice and turmeric. These all are natural indicators. Indicators is nothing but which changes its color, you can say, or a smell, color or a smell. By putting some like acid or some substance, if it changes its color, then you can say it's an indicator. It is indicating what is. The main basic thing is it is indicating it, whether it is an acid or a base or what is that added. Something, it will change its color. If litmus paper is there, it is going to change from blue litmus to red litmus when you dip in the acid, which means that yes, it is indicating that it is an acid. Indicator, which our signals also will indicate, right? Red, blue, green signals will indicate to go, to stop and to get ready. Like that, the same thing, they will indicate which they are, whether they are acids, base and what neutral substance they are going to indicators. Those are indicators. So now they turn, first point is a sour to taste. They are sour to taste. Sour, like grapes. How the grapes are? Grapes will be sour to taste, isn't it? And neem will be bitter to taste, isn't it? So which are sour to taste? Like grapes, like tomato. These are sour to taste. Those are sour to taste. And acids are again. So that's all with the acids. I'll come in more detail. First point is sour to taste. But don't taste all the acids. There are some acids which you can taste it, and by it you can say it. But all the acids you are not supposed to taste. For that we have taken what? Indicators. What we have taken? Indicators. Which indicators we have taken, which indicate whether it is an acid or a base. One of the important and famous is it will turn blue litmus paper to red litmus paper. Blue litmus paper will be there when you dip into the acid substance. It will turn into red. By that you can say, if suppose if blue litmus paper, if does not turn into anything, suppose that is not the acid. What is it? We will come in the next topic. You know already, isn't it? Then see, the acids are two types, isn't it? Organic acids, and mainly organic acids and inorganic acids. Organic acids and inorganic acids. What are these organic acids and what are these inorganic acids? What are these organic acids and what are these inorganic acids? Organic acids are those which we get from the plants, isn't it? Those are the organic acids, you can say. Such as oxalic acid is present in spinach and lactic acid in curd. If you taste it, it will be sour to taste, isn't it? Then uric acid, it is urine. In urine it is present. Acetic acid in vinegar, that they will add in the noodles to make it a taste. Vinegar, it will be sour to taste. It is also called as acetic acid. These are from plants. Okay, so organically, we are getting organically from plants, isn't it? Those are organic acids. And in aqueous solution, these are weak acids. These are not strong acids, these are weak acids. How can you say whether they are strong or they are weak? I am going to discuss it. They are weak acids and in aqueous solution. Their aqueous solution contains ions and molecules. Ions and molecules, both ions are positively or negatively charged. Suppose Na is there. Na is an atom, isn't it? Na plus ion. It is charged. Cl minus. It is charged. These are ions. If an atom is positively or negatively charged, then it is said to be what? Then it is said to be ion, isn't it? Then it is said to be ion. Like that. In this, there are ions and molecules. What are these ions and molecules and how can we know? I will tell you next. Inorganic acids which are obtained from minerals. Like these are very, very strong acids which we get from the minerals, like hydrochloric acid, nitric acid, sulfuric acid, H2SO4, HNO3. These all are the acids. If you observe, let me tell me one trick in this. If you observe, always remember acids will be starting with H plus ions, H plus, like HCl, H2SO4, next HNO3. These all contain H plus ions in their starting. By seeing that, you can easily say that they are acids. Got it? They get ionizes. I have used here these mineral acids are strong acids. They ionize completely. Ionization completely. They split completely in the water. You can ionize completely when these acids are added to the water. When these acids are added to the water, they are going to split completely. See here. Acids, I said you already. Ionization. What is that ionization? How the hydrogen atom is going to come out of it. Let us see in this. An acid may be defined as a substance which contains hydrogen when dissolved in water gives hydrogen ions, which contains compulsorily water. Hydrogen, which contains hydrogen and gives out water. Hydrogen ions when dissolved in water. Again, an acid may be defined as a substance which contains hydrogen and when dissolved in water gives hydrogen ions. When it dissolved in water, what it gives out? Hydrogen ions. It gives out. What it gives out? Hydrogen ions it will give. It has HCl, it has chlorine also. It does not give the chlorine. It gives the hydrogen ions when it mixed with the water. Remember, it contains hydrogen and when it reacts with water, it gives out hydrogen ion out. Remember, hydrogen ion out. Now, or hydrogen ions, hydronium ions. These are called as what? Hydronium. See, one H plus here. H plus H2O. If suppose I'm saying one H is coming out from the acid and when it combines with H2O, water, then what happens? H3O plus is going to form and it is called as hydronium ion. So what it is called? Hydronium ion. You are not supposed to call two hydrogen atoms or three hydrogen atom, one oxygen atom. No, it's hydronium ion. What is it? Hydronium ion. Remember, when what happens in the acids, first is it contains hydrogen and gives out what? Hydrogen ions. Ions are nothing but charged particles. I said H plus, Cl minus, Na plus, Cl minus, and SO4 minus, H plus, SO4 minus. These are the ions, charged particles. Charged particles are ions. What are these charged particles? When they gain or they lose the electrons from its outermost shell, then we say they are charged particles. In your atomic structure, you are going to learn very well. But I am saying you now. So these are charged particles. So they are going to leave ions, isn't it? NaCl is there. Na plus Cl minus is a combination. Isn't it? Like that. HCl is H plus Cl minus. So they don't give anything else. In acids, what they give mainly, they contain chlorine, they contain nitrate, they contain something or else. Only they are going to give what? H plus ions out, and forms that ions when they mix with the water. When one hydrogen atom is formed, a new one is formed, that is called as hydronium ions. What they are called? Hydronium ions. What they are called? Hydronium ions. Hydronium ions. Those are called what? Hydronium ions. H3O plus as a positively charged ions. Once again I am repeating. An acid may be defined as a substance which contains hydrogen, and when dissolved in water gives hydrogen ions H plus, or hydronium ions H3O plus. Hydrogen means H plus. Hydronium H3O plus ions are called as a positively charged ions. See here, H plus. Here are some examples. H plus plus H2O. This H, it will give out one H added to this, isn't it? See here, HCl is an mineral acid, just now we have learned. HCl, hydrochloric acid, plus H2O. When it reacted with water, when acid is reacted with water, what is released out as a positive charge? Hydronium ions. Positively charged hydronium ions. The Cl will not come here. ClO minus will not form. This hydrogen, immediately when you put the acid into the water, immediately it is going to split into hydrogen ions. In the water it is going to split into hydrogen ions. Okay, and this C, HNO3 plus H2O. HNO3 plus H2O. This hydrogen atom in this, we are going to combine with this, forming hydronium ions. And the next C, CH3COOH. See, here one hydrogen is there. Complete one hydrogen will combine with this H3O plus. Dissociate. From HCl, one hydrogen is there. HCl. That one hydrogen atom completely dissociates and forms H3O plus. Here also one hydrogen atom completely dissociates. It completely come away from this, isn't it? But in this you see CH3 COOH plus H2O. CH3COOH, acetic acid. This is what acid it is. What acid it is? Organic acids. You know already. Organic acids are weak acids. Why I said weak, you know? Because in this 3 plus 1, 4 hydrogen atoms are there. But when it is splitting, it will give out only one hydrogen. Only one it is going to give. Remaining 3 it will be with that only. So completely does not get ionizes. It does not get dissociates. The hydrogen atom does not get dissociates completely with that. So we say those acids as a weak acids. As we have discussed earlier, there are some indicators which indicates whether it is an acid or a base, isn't it? Whether it is an acid or a base. So one of our indicator is this all synthetic, you can say, like a methyl orange, litmus paper and phenolphthalein solution. Litmus paper is a strip of a paper which you get from a lichens extract. Okay, so it turns blue litmus to red litmus. When you dip in the acid, it indicates when you immediately dip in the acid, what happens to the blue litmus? It turns into red litmus. Methyl orange, what happens to this methyl orange then? This methyl orange, it is also one of the indicator. Also, it will be in a form of a solution. It will be orange, isn't it? It turns to red in color. When you put it in the acid, immediately it changes to red in color. And phenolphthalein solution. In this, what happens? If you add it, it will be in the pink. It will be turned into colorless. No color will be appear in the acid in the case of phenolphthalein solution. So HCl H is there. So it's an acid, isn't it? HCl, it will split. Strong acid we serve. So what happens to litmus paper? It turns blue to red. It turns blue to red. So what happens in the case of methyl orange solution? It turns into red, orange into red. Then what about phenolphthalein solution? It turns to colorless solution. What solution? Pink to colorless solution. Colorless solution. When H2SO4, yes, hydrogen ions are there, plus positive ions, H plus ions. So it is an acid, isn't it? How if some formula is given, you don't know what is whether it is an acid or a base. So immediately what you need to do, you need to immediately, and the hydrogen atom is there in that. It is a positive ion. Then immediately H first will be there. Blindly remember, first it will be there. Except for CH3COOH, like that some or one or two exclusives are there. Remaining all will be the first will be the H2SO4 hydrogen atom. Maximum the first will be hydrogen. So it is an acid, H2SO4 sulfuric acid, isn't it? The same. Blue to red. It turns into red color. It's colorless. HNO3, the same. CH3COOH, the same. Got it? So acid indicator, these are indicators. When they mix with, when they are added to the acid, they indicate by changing their color, they will indicate. By changing the color, they will indicate that yes, it's an acid, it's a base. They'll change their color. When you add to the acid, when you add to something, no, they'll change their colors. So by changing their colors, immediately you can know they are indicating it is an acid. What indicates what? When blue litmus paper turns into red, it indicating that the paper is indicating that you have added one acid. You can't taste all these. I said these are served to taste, isn't it? But you can't taste all these things, which will damage your tongue. So if you put these indicators, easily you can know whether which acid is added to it. Acid or bases are added to it. So next we will go with the bases. Now bases are bitter to taste, and they turn red litmus to blue litmus paper. They turn what? Red to blue. In acid, blue to red. Remember, red. If something acid fall on your skin, what happens? Immediately your skin will tear out and red color will come out, isn't it? So blue to red changes is acid, and red to blue is base, and they are bitter to taste. Very bitter to taste. And a base is an oxide, like copper oxide, zinc oxide, or hydroxide, like sodium hydroxide, KOH, of a metal, KOH, NaOH, metals, isn't it? Of a hydroxide of a metal, or aqueous ammonia, NH4Cl, aqueous, aqueous. It is something different from liquid, isn't it? Aqueous is something different from, if a solute is added something like to the solution, then it becomes aqueous solution, isn't it? So NH4Cl, which reacts with H plus or hydronium ion of an acid to form salt and water only. See here. Which reacts with H plus ions or hydronium. In the case of acids, hydronium ions are going to come out. When bases are reacted with this, CuO, basic oxide is a basic oxide. When it is reacted with acid, it gives what? Salt plus water only. Salt plus water only. Basic oxide. Okay. I said, oxides, CuO, ZnO, hydroxide of a metal, NaOH, KOH, or liquid OH. You can mostly, in our syllabus, mostly covered is this OH parts only. If OH is there, simply you can say that it is an OH minus. You can simply say that it is a base. Bases, some are water soluble, but some are water insoluble. Water soluble, they mix with the water. Water insoluble, they don't mix with the water. For example, water soluble are NaOH, KOH, NH4Cl. They are going to mix with the water. Water insoluble. The bases which are soluble in the water, they are called as, when the bases which are soluble in water, they are called as alkyls. Alkyls, isn't it? and water insoluble. Some bases are insoluble like CuO, PbO, ZnO. These all are in oxides, right? Oxides are insoluble in water. Water in bases are water soluble and water insoluble. Bases either can replace oxide ions, OH minus ions, or hydroxide ions. In that H plus, isn't it? In acids, what H plus ions are going to get replaced? In bases, OH minus, and sometimes O minus also, oxides also. Or oxide replace oxide ions or hydroxide ions. So see here, MgOH2 basic hydroxide. Basic hydroxide plus H2SO4 is an acid, isn't it? They are going to form water, MgHO4 plus H2O. The OH minus ion is going to come out. I'll show you. I'll show with some more examples. But what you, in an aqueous solution, what happens? Bases either contains, either they replace oxide ions, OH2 minus, or hydroxide ions, OH minus. So let's see. Now you see, HCl. H is plus. H plus ion is going to come out when you add to the aqueous solution. H plus, H only. Weak acid, but it's H. NaOH base, OH base, OH base, OH base. H plus ion, OH minus ion, isn't it? OH minus comes out in the aqueous solution, ionizes, it means that it is a base. When H plus ions comes, it is an acid, HCl. It turns blue litmus to red litmus paper. And red to, it will not have any change. Methyl orange to red, phenolphthalein to colorless solution. H2SO4, red, no change, red, colorless solution. CS3COH, red, blue to red it changes. In red, no change will be there. And NaOH, which means that it has negative OH. Isn't it? Means it is a base. OH, it is a no? OH minus. It is a base. So base in the, if you put blue litmus paper in the base, it will be in blue. It will be red if you put, it will become what? What? It will become, when you put red litmus paper, it becomes blue. It changes red to blue. In blue, it remains the same. Actually, it does not turn into blue, it remains same, you can say. It remains same. And blue. And methyl orange, when you add to the base, it becomes yellow. Phenolphthalein solution, pink. In acid, if you put the phenolphthalein solution from pink to colorless, it becomes. When you put in the base, it will be pink. And MgO2 is also an acid. It turns blue to red, blue to nothing. No change. You can say no change. No change or remains same. As it is blue litmus paper now, that's why. When you give red litmus paper, it becomes red. Okay. When you give orange, yellow. Phenolphthalein, pink. So till now, you saw the indicators which changes, the substance which changes color. Isn't it? By adding acid or a base is an indicator. You saw color indicators. There are some indicators which change their odor, Another type of indicators are there. Those are olfactory indicators. So till now you saw indicators are going to change their color, isn't it? When indicators change their smell or odor, then we say those indicators as olfactory indicators. So now take a cloth. Take a cloth and put onions in this and fold it and put it in the fridge. So to the next day morning, you take strips of onion cloth. It smells like an onion, isn't it? Onion cloth strips. And in next, take clove oil. Take what? Clove oil in these both. What you take? You take clove oil. Okay. And okay. Next, vanilla essence. vanilla essence. Essence you add. Vanilla essence you add. Then what happens? See here. Then when onion cloth is there, when you put NaOH to it, means what NaOH means? OH, base, HCl. Here also NaOH, HCl. NaOH, HCl. What they have to change? They have to change the color? No, they have to change the smell. So when you add NaOH to this strip, if you add NaOH to these strips, what happened? It is a base, isn't it? It is a base. It changes its smell. The cloth changes its smell if you add it. But in HCl, it does not change any color. So, to the cotton cloth, if you don't know what is the substance it is, whether it is an acid or a base, to a cotton cloth, if you add that substance and if it changes its smell, then you can say it's a base. When it does not change its color, it is said to be acid. And in the clove oil also the same. NaOH in the clove oil, clove will be smelling very hardly, isn't it? So when you add NaOH to that, then the clove vanishes. The characteristics of clove oil will vanishes. But in the HCl, it does not vanishes. Vanilla essence also, the smell of the vanilla essence vanishes in the case of adding NaOH. But by adding HCl, it does not vanishes. So from this, you can say that the smell, the indicators, these indicators, if that indicator is added to it, it's changing. When acid is added, it is changing. When base it is adding, it is not changing. Which means that, so it is indicating it. The substance it is indicating it. It is acid or a base, it is indicating. Those are olfactory indicators. Olfactory indicators. I hope you understood well. Next. So, acids, bases, indicators, blue litmus paper, red litmus papers, red litmus paper, blue litmus paper, or methyl orange, phenolphthalein, olfactory indicators. I hope everything you got understood.